Find the condition that the circles, that you are given two circles, you have to find a condition for touching, right? Two circles can be touched internally or externally, right?
Yes, sir.
Like this. Two circles, if they intersect like this, or like this. This externally touch, this internally touch. This known as internal touching, this externally touching, right? In this case, C1, C2 equals C1, C2 equals R1 plus R2. Okay?
Okay, sir.
Then this is C1, C2. Here C1, C2 equals, if they touch internally, R1 minus R2. But we don't know which one is bigger, no? In this case,
Yes.
but according to,
Yes, sir.
I have drawn like this, R1 is bigger, but we don't know which one is bigger, so you have to put R1 minus R2 absolute
Modulus.
value, modulus, right? So generally you can say C1, C2 equals R1 plus or minus R2. For both cases, if you combine, right?
Yes, sir.
If two circles touch each other, two circles touch each other, then C1, C2 equals mod R1 plus or minus R2. What do you think about this? Is this answer is enough or not enough? They are asking the condition for that, right? So this circle is x squared plus y squared plus 2g1x plus 2f1y plus c1 equals 0. This circle is x squared plus y squared plus 2g2x plus 2f2y plus c2 equals 0. What do you think, Julie?
It is enough, sir.
No, I think. Right? I didn't look at the mark scheme now. I think this is not enough because sometimes they might, the paper maker can give answer for the marks for this one, right? But we
Yes.
have to provide complete answer, right? R1 and R2 are our terms, right?
Yes, sir.
Their terms are these terms, right? G1, F1, C1 and G2, F2 and C2. Those are their
Yes,
terms.
sir.
So we have to provide the answer using their terms, right? So C1, C2 is actually G1 minus
Sir.
G2 squared. Yeah.
Sir, okay, so I was thinking that sir is going to use C1, C2 again for this question, for the next step, sir. That's why I was going to ask, don't we need
But
to
you have to
use
keep
that method
keep
for
in mind.
sentence?
But you have to carefully handle. But C1 and C2 use for. If he also C1, C2,
Yes, sir.
this C1, C2 are not there, those. You don't mix up that. You can use that no matter, no problem. But
Okay.
you have to keep in mind, right? This C1, C2 are the points, right?
Yes,
Not
sir.
these C1 and C2, right? Uh, if you think it is problematic, you can use another symbol, no matter. But you can use
Okay,
that,
sir.
never mind, right?
Okay,
This
sir.
equals R1 equals G1 squared plus F1 squared minus C square root plus or minus G2 squared plus F2 squared minus C2. And like that. So you have to keep the answer in this form, like this, right? Okay,
Okay, sir.
right? Right.
Sir, don't we need to solve?
You can't solve that. No, you can. You actually you can't simplify further. If you if you try to simplify this one, yeah, you can, by squaring both sides you can simplify up to some extent, but that is not necessary because they have not asked, they have not mentioned any relationship, right?
Yes, sir.
So we can leave this answer at our disposal, right? In a way
Okay, sir.
convenient for you. Uh, don't worry that. So you can same time you can look at the mark scheme if you have how they have given the answer. But although I think all one can simplify further, but they can't give marks further because one can stay at this point, right?
Yes, sir.
Right. Okay. Now let's see next part. If you look at next part, so you have to show the contact points of these two circles, right? Lies on these straight lines. If you look at first straight line, it is actually radical axis actually, right? If you take difference of circles, normally you get radical axis, right? But if you look at next line, actually, if you look at the gradient of this line, what can you say about the gradient of this second line, Dewey? What is the gradient of
F1 minus F2 and
F1 minus F2
F2.
over G1 minus G2? No, F1 minus
Yeah.
F2 over G1 minus G2 over F1 minus F2.
Sir, isn't that F1
No,
minus
no, no,
F2
no, no.
over
Yeah,
G1?
F1 minus F2 or G1 minus G2. That is actually gradient of the line joining centers, right?
Yes, sir.
That is the gradient of C1, C2 line. So you can guess actually this is the line because you know always contact point is on the line joining centers. It is obvious, no? Right?
Yes, sir.
It is obvious. You can mention that. Then how do you show that first line? First contact points on the first line. How do you show that? What is the easiest way to do that? What is the easiest way to do that? Let's say contact point x0, y0. Okay?
Okay, sir.
X0, y0. If contact point x0, y0, let x naught y naught be the contact point. Then x naught y naught satisfy in circle 1, first circle. Then x naught squared plus y naught squared plus 2g1 x naught plus 2f1 y naught these contact points lies on both of the circles, right? So therefore x naught y naught you can substitute x naught y naught in these equations. X naught squared plus y naught squared plus 2g1 x naught plus 2f1 y naught plus c1 equals 0. See, so if you take other circle, x naught squared y naught squared plus 2g2 x naught plus 2f2 y naught plus c2 equals 0, right? Now you can subtract these two equations, right? You take 1 minus 2 by 1 minus 2. Two g1 minus g2 times x naught plus 2 f1 minus f2 times y naught plus c1 minus c2 equals 0. So what is this doing? What is this?
Equation of a straight line, sir?
No, this is not a straight equation of a straight line. This is just equation, but this is actually, this shows x naught y naught has satisfied in a straight line, right? In an equation of a straight line. Right? Because x naught y naught is fixed point, right? If you subtract these two lines, right, this is actually showing that x naught y naught make this x naught y naught satisfy this certain equation, right? This something like this. X naught y naught is a point. Let's say I am taking another example, right? 2x plus 3y minus 4 equals 0. Is this a line? What is this? This is a straight line.
Yes, sir.
This is a straight line. 2x naught plus 3y naught minus 4 equals 0. This is not a straight line. What can you say from using this equation? If this is true, if this equation is true, what is your conclusion?
X naught comma y naught be can be an any point on
No, x
2x
naught y
plus-
naught is on this line. The simple thing is that
yes, sir.
x naught y naught is on this line, right? If this is true, that means x naught y naught is on this line, on this straight line, right? Likewise, you can say x naught y naught, the contact points Therefore, the contact point x0 y0 is on the line 2g1 minus g2 x plus 2 f1 minus f2 y plus c1 minus c2 equals 0. Is it clear? Not clear?
Clear, sir.
Clear, right, okay. Very clear,
Yes, sir.
right. Then how do you show the second line? The contact point lies on the second line. How do you show that? So, this is the easiest way to show. First line is contact points lies on the first line. Now, but you are given two straight lines. Now you have to show contact points on those lines, right? Okay. So this is the easiest way to show that. Second line, you can say, you can start x0 y0 lies on the line C1 C2, on the line C1 C2, that is line joining centers. It is obvious,
Yes,
no? Right? C1 C2, x0 y0, the contact points lies on the C1 C2. Now you find the equation of C1 C2. What is the equation of C1 C2? The equation of C1 C2 is y minus f1 over x minus y plus f1 x plus f2 g1 equals f1 minus f2 over g1 minus g2. Straight away you can write down the equation. So y plus f1 times g1 minus g2. You just look at how they are. So you can use f2 g2 also here, no? Right? Which one they have used, you have to just check. That is y times g1 minus f1. Right, okay, same thing you get. Plus then x plus g1 times f1 minus f2. So this equals y times g1 minus g2 plus minus x times f1 minus f2 plus f1g minus f1g2 minus g1 f1, sorry, here f1g1 plus g1 f2 equals 0, right? So this equals y times so these get cancelled. Plus g1 f2 minus g1 f2 minus f1 g2 equals 0. Okay. Hello?
Okay, sir. Oh, sir. Nine.
Right. Package do you get all?
Oh, sir.
දැන් මේක තියෙන්නේ. So you just check the second equation. Yeah. F1 minus F2 times x. So you can write taking x first terms. So x into F1 minus F2 minus y times g1 minus g2 plus F1 g2 minus g1 F2 equals 0, right? So because we started like this, we started with x naught, y naught, like C1, C2, and you got the equation of C1, C2, right? So therefore, the contact points x naught, y naught lies on this line. Right? On this line. Well, අපි මුලින්ම පටන් ගත්තේ x naught, y naught be the contact points. මේක. Right?
sir.
එතකොට අපිට පුළුවන් දැන් එතකොට අපි contact point එක තමයි අපි contact point එක අනිවාර්යයෙන් මේ C1 C2 රේඛා මත පිහිටන. මේක C1 මෙතන C2. C1 C2 රේඛා මත පිහිටන. Right?
Sir,
Oh. The next part is show that this you are given two circles, touch each other externally and find the coordinates of capital A, the point of contact of the two circles. Right? Now you have to find the point of contact of two circles. So if you subtract two circles, you can get radical axis or common chord or common tangent, right? Then you can find the centers of two circles. You can find the equation of the line joining centers, right? Then you can solve those two equations. Then you can find the contact points, right? Let's see how you can do that. The center of the first circle, C1. Now you have to show these two circles touch externally, right? Touch externally. Then C1, C2 should be equal to R1 plus R2. So you take the center of the first circle, 1 minus 2. Radius G squared minus 1 squared plus 2 squared minus 0 whole thing square. That is square root 5. Then if you take second circle, x squared plus y squared minus 10x plus 20 equals 0. Center C2 is 5, 0. Right? Radius R2 equals minus 5 squared plus 0 squared minus 20 whole thing square. That is square root 5. Right? What is C1, C2? C1, C2 is 1 minus 5 squared plus 2 squared whole thing square root. That is 2 root 5, no?
yes, sir.
2 root 5. That means C1, C2 equals 2 root 5. What is R1 plus R2?
2 root 5, sir.
2 root 5, right? R1 plus R2 equals 2 root 5, right? Therefore, two circles touch externally, right? Two circles touch externally. Then point of contact. How do you find the point of contact now?
By equalizing circle.
But then now contact point, now R1 equals R2. R1 equals R2. Therefore, contact point, the contact point is midpoint of C1, C2. Therefore, A equals midpoint of these two, that is 3, that is 1 plus pi by 2 plus minus 2 plus 0 by 2. That is 3 minus 1. Okay. So this is the contact point A, right? Next part is P is a point such that the length of the tangent from P to the first circle is k times that of the tangent from P to second circle. Prove that if k is k square not equals 1, the locus of P is circle to capital A and find its equation terms of k, right? So very simple. So like this, two circles. So this circle is this circle is this, right? Two circles. Now PR is k times PS, right? Then PR square equals k square PS square. What is PR doing? What is PR? PR. If you take this point is x naught, y naught. What is PR? Length of the tangent. We did that. As a theory part, we did length of the tangent. Length of the tangent is defined as the distance from that point to the tangent. So circle to the circle. So you can find this distance PR. We substitute x naught, y naught in this circle, in this equation. Now, if you want to find PS, you substitute x naught, y naught. So this is the second circle. You substitute x naught, y naught, this second circle. So PR is this. Then you take the square root. PS, you can find PS by substituting in second equation. X naught, y naught. That is, then take square root. X naught squared plus y naught squared minus 10x naught plus 20 all things square root. Now PR and PS you can substitute in this relation because they have given that length of PR is k times length of PS, right? So if you square this you get this one. Now if you substitute in equation 1, in this equation you can substitute these values, then you get like this, right? Then take all terms to one side, then 1 minus k square times x naught square plus 1 times 1 minus k square times y naught square, this much times x, and y is naught minus 20k squared equals 0. What is this? But x naught, y naught is a variable point. So instead of x naught, y naught, you can substitute xy because it's a variable point. Since x naught, y naught is a variable point, substituting xy instead, then y 1 minus k squared times x, 1 minus k squared times y squared, plus minus 2 plus 10k squared times x, plus 4y minus 20k squared equals 0. Right? What is this? If k squared equals 1, no squared terms. That means if k squared equals 1, this is a straight line. But if k squared is not equals 1, right, this is a circle, because if k squared is not equals 1, but coefficient of x squared equal to coefficient of y squared. Therefore, this is equation of a circle, right? This is the equation of a circle. Of a circle as k square not equals 1. Right? So now you have to check whether point A satisfies this equation. Right? If you substituting the point 3, 1, the coordinates of A, 3 minus 1, right? 1 minus k squared times 9, 1 minus k squared times 1, plus minus 2 plus 10k squared times 3, minus 4 minus 20k squared. So this LHS equals 9 minus 9k squared plus 1 minus k squared plus minus 2 plus minus 6 plus 30k squared minus 4 minus 20k squared. Now k squared terms get cancelled. 9 10 minus 10 equals 0, equals RHS. That means therefore A lies on this circle. A lies on this circle.